Hi, how are you guys doing? Hope you're doing good. Today you're going to learn about the sum and difference identities. And what the sum and difference identities help you do is find the values of sine, cosine, tangent when the angle is not on the unit circle. I know we have calculators to do that. I know we have Desmos now, but sometimes you need an exact answer. So that's what these are going to help you do. Right? Okay, so there is my screen, and here are your notes. So you guys are going to need to pause this and copy those down for your notes. These are not formulas that I'm expecting you to memorize, but you will have to be able to use them. So you can have them out next to you. You don't have to worry about ever being tested on them without them being provided for you. But basically, as you can see, there's a cosine, sum, and difference. There's a sine, sum, and difference. And there's a tangent, sum, and difference. Okay, so again, these are used for angles not on the unit circle. All right, so go ahead and pause this and take those down. Okay, so what these do is you're basically using angles A and B in your formula. Whoops. Are angles we know on the unit circle. Okay, so we want to use angles we know on the unit circle in order to either add those two angles and get the one we're trying to find, or subtract those two angles to get the one that we're trying to find. Okay, so here's a couple of examples. Okay, so we're going to use the sum identity, to find the exact value of cosine of 75 degrees. Okay, so 75 degrees is not on our unit circle, so that's why we have to use a sum identity. Okay, so from your previous page, you should see that the sum identity, remember sum means add, cosine A, cosine B, minus sine A, sine B. Okay, a lot of you may say, well, how do I know to use cosine? That's because I'm finding the cosine of my angle, so I would need to use the cosine sum formula. Okay, so I want to find two angles, A and B, that add up to be 75. Goals would be to try to use angles between 0 and 360. You can always use negative angles, but don't make your life harder when it doesn't have to be. So two things that can add to be 75 are what? 45 and 30. Okay, doesn't matter what's A, what's B for the adding ones. Remember, adding can be done either way, but I'm just going to make 45A and 30B. So I'm going to plug everything in. Okay, so I'm going to say cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. Okay, so remember that the cosine of an angle is the x coordinate and the sine of an angle is the y coordinate. Okay, so the coordinate at 45 degrees is square root of 2 over 2, comma square root of 2 over 2. And at 30 degrees, it is square root of 3 over 2, comma 1/2. All right, so the cosine at 45 and the cosine at 30 is square root of 2 over 2 and square root of 3 over 2. Okay, so this is square root of 2 over 2 times square root of 3 over 2. Okay, then minus, and then we've got the sine of 45 and the sine of 30 are square root of 2 over 2 and 1/2. Okay, so that is square root of 2 over 2 times 1/2. Okay, so I'm just going to subtract, or I'm going to multiply what's inside my parentheses. So this is square root of 6 over 2 minus square root of 2 over 2. And I want to simplify it as far as I can. So we've got common denominators. So I'm just going to do square root of 6 minus square root of 2 over 2. Okay, and if you use your calculator, okay, in degree mode, because our angle is in degrees, so I'm going to change mine to degree mode. And I press cosine of 75 in the calculator. I get 0.2588. Okay, so that decimal should match this. So let me do that. So square root of 6 minus the square root of 2 divided by 2 does not give me that because that is wrong. Sorry guys, go back a little bit. When I multiplied, when I did 2 times 2 here, that should have been a 4. And when I did this 2 times 2, that should have also been a 4, so that would have made that a 4. Okay, so now when I retype that into the calculator and do divided by 4, I get my 0.2588. Okay, so that's a really good way to check your answers. As you can see, I made a very simple mistake and it's very easy to do that. Okay, so let's do the next problem. All right, so this one may seem like it's the same, but it says use the difference identity. Okay, so that means instead of adding 2 angles, we're going to be subtracting 2 angles. So we're finding the exact value. Exact means no decimals, so you're not using your calculator, of cosine of 75. Okay, so from the very first page, oops, that's weird. Okay, from the very first page of notes, you'll see that cosine A minus B is cosine A cosine B plus sine A sine B. Okay, so just because we're going to use different angles and a different formula does not mean we should get a different answer. So we should still get radical 6 minus radical 2 over 4, or 0.2588. Okay, we're still going to get that, but it's just doing it a different way. Okay, so I want to do find 2 angles on my unit circle that when I do A minus B, I get 75. And I can do 120 is A, and 45 can be B. Okay, so we've got cosine of 120 minus 45 equals cosine of 120 times a cosine of 45 minus sine of 120 times the sine of 45. Okay, so remember that cosine is the x-coordinate and sine is the y-coordinate. 120 degrees, we've got negative 1/2 comma root 3 over 2 as our coordinate, and 45 is root 2 over 2 comma root 2 over 2. Okay, so the cosine is the x-coordinate, so the cosine at 120 is negative 1/2, and the cosine at 45 is root 2 over 2. Okay, and then the sine at 120 is root 3 over 2, and the sine at 45 is root 2 over 2. Okay, so when I multiply these, I get negative root 2 over 4 plus square root of 6 over 4. Okay, my denominators are the same, so when I combine them, I don't have to do anything, and I get that answer. Okay, that answer is the same as this answer because square root of 6 is positive, square root of 2 is negative. So they end up being the same thing, and they both equal that decimal. Okay, so that is how you use your difference identity. It is the same way when you're using sine and tangent. You're just plugging things in. Tangent, I'll do some tangent examples tomorrow. It's a little bit more complicated when you're simplifying stuff because of the fractions. But I'll do one last example with sine, and we're gonna actually use a sum or difference, doesn't matter. And this one starts out in radians. Okay, so again, remember that these are not on the unit circle. So when I see this, I can't just go find it on the unit circle. I need to convert my radians to degrees. So remember, your converting radians to degrees formula is your angle times 180 over pi. So I'm doing 11 pi over 12 times 180 over pi. Okay, and when I get that, I can cancel out my pi's, and I get 11 times 180 divided by 12. That gets me 165 degrees. Okay, so instead of 11 pi over 12, I'm going to use 165, and that's perfectly fine for you guys to do. I know I always tell you to work in radians if you have radians, but when it's not on the unit circle, don't worry about it. Use degrees, it'll be easier. Okay, so we've got sine of 165, and I actually want to use my sum formula. So the sum formula is sine A cosine B plus sine B cosine A. Okay, so if I want to find two angles, A and B, that add to be 165, and that is 135 and 30. Okay, there might be others, and that's fine. You're gonna get the same answer either way, but these are the ones I picked. So I'm just gonna plug everything in. So sine of 135 times the cosine of 30 plus sine of 30 times the cosine of 135. Okay, again, your sine is your y, cosine is your x, and the coordinates at these 2 points. Again, I'm finding these on my unit circle. I'm not making these up. These are all coordinates from the unit circle. So those are my coordinates for those two angles, and sine of 135 is my y coordinate, and then cosine of 30 is my x coordinate. Okay, sine of 30 is the y coordinate, so 1/2, and then cosine of 135 is the x coordinate. Okay, so I multiply, I get radical 6 over 4 plus negative radical 2 over 4. Okay, and then when I simplify, it's radical 6 minus radical 2 over 4. Okay, and again, I can check on my calculator. So if I do sine of 165, I get 0.2588. This is actually the same exact answer as the other one, and that is perfectly fine. Okay, so I hope that helps. Your homework is in Canvas, and it's a worksheet, and you'll see the numbers that you're supposed to do, but I need you to turn in notes from this video and your work for the worksheets. Okay, make sure you show your work because the answers are there so you can check them. All right, see you next time.